Welcome. This is lesson 7.7. This is it's kind of out of sequence a little bit, but it's the second lesson of chapter 7, even though it's 7.7. This is the first day of the second lesson of chapter 7. And not sure what season we're on, but let's continue. You guys have done this before. Left endpoint approximation, right endpoint approximation, midpoint approximation. There were some formulas for it. You guys remember the formulas a little bit? Probably didn't use them much because I told you not to. But you got the base times the height on the left-hand side. Base times the height on the left-hand side, base and the height on the left-hand side, and so on. Then you have base times the height on the right-hand side, base times the height on the right-hand side to the right. In this one, you did base times the height at the midpoint. This is the base times the height at the midpoint. So what's the difference? What's new with today's? Well, today we're going to use trapezoids. Today we're going to use trapezoids.
But why?
Well, why? Good question. You might think trapezoids are more accurate than the midpoint. Not true. Midpoint's more accurate. Yeah. So that's a great question. Why would you use trapezoids?
There's no point.
Trapezoids, you can think of it as an average of the right hand and left hand. And so if you're going to get one of your approximations, right hand is too high and left hand is too low, then an average of those would be a more accurate than either the right hand or the left hand. Okay? But if you got the midpoint that's available to you, then you should use the midpoint. However, it's not always available, right? We don't always know what's the height here. We don't know the height in the midpoint always. If you had that available to you, I would say definitely use that. It's going to be more accurate. But if you have only these the right hand side and the left hand side, you could use trapezoid some, and you can get a more accurate reading than you could if it were a left hand or a right hand. Is that clear? So I'm going to show you what's the deal, and we'll see if there's any questions and so on and so forth. We'll go over some problems. I don't know what's going on here. Okay. So remember that the area of a trapezoid is 1/2 base 1 times plus base 2 times the height. Okay, that's the area of a trapezoid. The trapezoid is untraditionally placed on its side. You guys usually picture trapezoids and the base and the top and the bottom. Usually this is your typical picture of a trapezoid. Right? You got your base 1 down here, your base 2 up here, and you got your height measured somewhere in between them. Your height is the distance between the bases. Agreed? Well, these trapezoids are turned on their sides. So your height is actually what we would, before when we did left and right hand, we called this the base. Now we're calling it the height. So our base 1 is here, our base 2 is here, and our height is the distance between them. All right? Now, if we're given a table, we can just look at those measurements. Left-hand side, right-hand side, those are our two bases. Our height would be the distance between them. And so on and so forth. So let's try a couple problems. All right? Notice this is double starred, so this must be super extremely important. If you have the time, you can always calculate the left endpoint approximation and the right endpoint approximation. Then add the two approximations together and divide the sum by 2. This will give you the same approximation as doing the trapezoidal approximation. So if you never want to do a trapezoidal approximation, you can just do the left, do the right, and then take the average. Kind of a long process for just wanting to skip something. Okay, let's see what happens when we do a problem. This is our integral. We're going to approximate, for each integral, calculate the midpoint approximation and the trapezoidal approximation based on how many rectangles we got, using n equal subdivisions. At the bottom, we'll do the irregular subdivisions. All right, so let's start with the midpoint, since we know that one well. Midpoint is in blue. Okay, midpoint. We're going to basically have to figure out from 0 to 2 how wide are these things. So a lot of times when I do these problems, I'll just draw a little number line. I say, well, here's 0, and here's 2, and I need 4 subintervals. I need 4 rectangles. So this would be 2, and if I do this, it would be 4. So this is going to be 1. We got 0.5, and we got how about 3 halves, or 1.5. So I've just created myself 1, 2, 3, 4 rectangles. Each rectangle will have a width of what? Yeah. Oh, yeah. All right. Now, what we need then is we need to figure out where are the midpoints going to be from these rectangles. Okay, so we have rectangle 1. Let's just do this. Rectangle 1. It's going to have some height over here, some height over here. What we're concerned about is the midpoint. So where do we need to calculate the height of these rectangles? We're going to want to calculate it here at 1/4. Here at 3/4. How about over here? What's this one called? 5/4. And if you want to use decimals, you can. 1.25. That's fine. And this one? Not quite 8/4. How will we get these heights? We figured out where we're going to calculate the heights. How will we get them? Michelle?
Plug it into the.
Say it a little louder.
Plug it into that.
Into this here, 2x to the third?
Into the integral and then.
No, you plug it in there. You had it right the first time. So let's do that. We're going to figure out what is, if this is our function, we'll say f of x equals 2x to the third, then we're going to need to figure out what is f of, 0.25. What is f at 0.75? We need to figure out, what I'm doing here is I'm calculating the heights at the midpoints. Calculating the heights at the midpoints. What is f at 1.25? And then what is f at 1.75? So someone with a calculator, hopefully many of you have your calculator out for this, but could someone throw in and get some values for us here?
1/4
Okay, go ahead.
is 0.03125.
Thank you.
At 3/4, it's 0.84375.
Thank you.
At 5/4, it's 3.90625.
3.906.
Yeah, 25.
25.
And at 7/4, it's 10.71875.
Okay. So what we calculated is we calculated the heights at each of these locations. So do we add these up and that's our integral? What? No, of course not. We gotta multiply these heights by how wide they were, right? They're half wide. So let's calculate. Area 1 is going to be this 0.03125 times the 1/2, which is their width. Each of these will be multiplied by half. So could we add them all up and just multiply by half at the end? It'd be the same, wouldn't it? So if someone could do that for me, we're going to add up all of these heights, and then we're going to multiply each of them by half. So it's going to be essentially the same thing, but for time's sake, someone add all these up and then multiply by half for me. Area 2. Area 3. And area 4. When you get an answer, just
7.75.
that's the final answer?
I don't know.
7.75?
Yeah.
2 people got it? Let's go with that then, 7.75. This is our approximation, the integral from 0 to 2 of 2x to the third dx is approximately, don't forget it's approximation, 7.75. Based on our midpoint Riemann sum. Midpoint is approximation. Now we could integrate this and get an exact, right? This one you made the heart of an integral.
How are the trapezoids relevant to this?
How the trapezoid relevant to this? Let's do it. We're about to do it right now. Trapezoid's going to make it so that we can be less accurate.
Why?
Exactly.
If you don't have the.
If we don't have the midpoint, we have to use it. Thank you. I took your 10 minutes. I didn't put it in the computer yet, though. All right, it's time for the green, which is a trapezoid. By the way, maybe someone who's quick with integrals, go ahead and tell us the exact integral. 0 to 2 of 2x to the third. You can use calculator if you want. I'm just trying to get an actual. Exactly 8?
Yep.
Hey, nice.
8.
Be a nice number.
Okay? Your integral will be 1/2 x to the fourth. Plug in a 2. Get 8. Alright, so the actual is 8. Our midpoint was 7.75. Alright, let's try try the trapezoid. So what happens in the trapezoid, we got the same number line going. We still got our distance between the trapezoids is still going to be half. So it's 0 to half, half to 1, 1 to 3 1 to 3 halves, and then 3 halves to 2. But this time we're going to have to calculate our heights here and here, here and here for our second trapezoid, here and here for our third trapezoid, here and here for our fourth trapezoid. So remember our trapezoid, area of a trapezoid is 1/2 base 1 plus base 2 times the height. So we need to calculate all of our trapezoid. Area of trapezoid 1. And there's a shortcut I can show you afterwards. It's similar to what we did at the half. But let's calculate our heights. 1/2. So base 1 would be when you plug in 0 into the function. It would be 0 into this function would be 0. So it would be f of 0. Plus, you plug in the function, you plug in a half. F of a half. Times the distance between them. The height here, ladies and gentlemen, is the distance between the two bases. So this can be kind of confusing. This half comes from the formula. This is the height, is the distance between the two bases. So they're both a half in this case, but that's just a coincidence. Okay, can someone give me the area of trapezoid 1? Someone punch in the calculator and tell us what it is? 1/16. Okay, area 2. Now this one we're going to use 1/2, and we're going to use f of a half plus f of 1 times the distance between them, which is a half. You plug these into here. Okay, plug into here. So if you just want to find these heights real quick, then you could throw them in here. This is what we did here. We found the heights, and we just plugged them in over there. So what do we get for this one?
9/16.
And then area 3, 1/2 times f of 1, because we're going to be here and here now. So f of 1 and then f of 3 halves. Times the height, which is a half. That's your distance between them. We get an answer for that one yet?
27/16.
27 or 16. And then over here, area 4 is 1/2 times your base 1, which is going to be f of 3 halves, plus your base 2, which is f of 2, times your distance between them. And you get what?
91/16.
You said 91/16?
Yeah.
Can someone add all those up? Can we get more than one person to add them all up? This is your integral based on the trapezoid would be the integral from 0 to 2. So give me a decimal. Give me a decimal for it.
8.0.
Say a little louder.
8 on the nose.
Yeah, it's 8.
It's it's 128/16, which is 8.
Well, that doesn't make much sense. You got exactly 8 for this?
Yeah.
Is there an error somewhere? I know, but midpoint's supposed to
I
be
got
closer.
8.5.
8.5. So one of these fractions might be off.
So we don't actually even know this trapezoid thing.
What? Yeah, you definitely need that. It's on the EP test like almost, I'd say, 2 out of 3 years. It's often on there.
Third one's off.
Third one?
Third one's off.
It's not 27 or 16? It
That's my bad.
should be what?
35 over 16.
35 over 16. Okay, thank you. No problem. Okay, 35 over 16. So we get 1 16th, 9 16th, 35 over 16th, and 91 over 16th. And it's approximately 8.5. So as you can see, midpoint's going to be more accurate than the trapezoid. Trapezoid is 8.5. All right, so quick recap. Now, some of you that are interested in shortcuts, you'll notice that there's f of 1/2 occurs twice. F of 1 occurs twice. F of 3/2 occurs twice. All of them are multiplied by 1/2 twice. So there are some shortcuts that can be made, right? You could do f of 0 once, plus 2 times f of 1/2, plus 2 times f of 1, plus 2 times f of 3/2, plus f of 2. Add them all up, multiply by 4. Okay, a little bit of a shortcut. But when you see that in the book, you'll know where that came from, because they get in the book they map it all out. But to me, with 4 trapezoids, I like to just do it 4 times. That's just me though, because it doesn't take that much longer. But it is a shortcut to do it the other way. Notice that it'll always be true. You'll have one of the left-hand farthest left, one of the farthest right. You'll have 2 of these, 2 of these, and 2 of these heights. What questions do you have, ladies and gentlemen? Olivia, did you get a chance to do the warm-up? All right, let's try one with irregular partitions. I'm going to skip the second one for now. Number 3, approximate the following integral using the trapezoidal approximation with irregular partitions. Now, ladies and gentlemen, you don't have to do this, but I'm just going to map this out real quick and put it on the coordinate grid and see if we can figure this. So we get this. Alright, so we're going to integrate from 1 to 4. So we get, let's do this. Put 4 over here. And if I plug in a 1, we need to figure out the heights of each of these. So if I plug in a 1, what's the height? 1/2? Okay, we'll put a 1/2 up here. Okay, so 1.5. Now we plug in 1.5. Did someone plug in 1.5 and tell us?
0.6.
What'd you say?
0.6.
0.6. I gotta run out of space. So we got 0.5, 0.6. All right, how about a 2.24?
0.691.
All I'm doing, ladies and gentlemen, is I'm taking these values, I'm taking all of these are x coordinates, I plug it into the function. Okay, over and over again, I'm getting the heights. Okay, how about 3? 0.75? What's that?
Yeah.
And how about 3.6?
0.783.
0.783. And then how about 4?
0.8.
I don't know. We're just getting an approximation. All right, that's at 4.8. Okay, what we have is we got to build trapezoids. We're going to build a trapezoid that goes from here, and our second one's 1.5, to here. We're just building a trapezoid. Again, you do not have to draw this graph if you can understand, conceptualize what's going on. But this is my trapezoid 1. And then from 1.5 to 2.24, which I'm a little off on that one. Probably be something like this. This is trapezoid 2. And then from 2.24 to 3, this is trapezoid 3. You see what's going on now? You're calculating the heights at each of these x coordinates, and then we're able to calculate the area. We're going to do the area of each of the trapezoids. All right, and then we got it at 3.6. That's our trapezoid there, and then at 4 goes up to 0.8. So trapezoid 4 and trapezoid 5.
Wait, is there 0.71 in there?
There's 0.75, 0.783, and 0.8. 0.75, 0.783, and 0.8. So now we have to calculate the area of each of these trapezoids, and then we have it. But we had to, they didn't give us the heights, so we had to use our function. They didn't give us a table of heights. If they gave us a table, they had these heights, that would be a little simpler problem, but we had to plug it in and get the heights based on where we're at. Okay, so let's try this now. You ready for this? Trapezoid 1. That has irregular partitions means we can't just multiply everything by the same thing because the distance between us will be different each time. So trapezoid 1, remember, area of a trapezoid is 1/2 base 1 plus base 2 times the height. So trapezoid 1 is 1/2 base 1. Anybody? 0.5. Okay? It's the height on the left-hand side. Base 2. 0.6. The height, what's the distance between the two bases? 0.5. Yeah, exactly. Because we're going from 1 to 1.5. This distance across is 0.5, so we multiply it by 1/2. Can someone go ahead and calculate that real quick before we move too far? It'll be 0.5 times 0.5 times plus 0.6 times 0.5. Can you give me a decimal? Anybody?
275.
Say a little louder.
0.275. Might be wrong.
Okay, trapezoid 2, we get 1/2 times, now we're doing trapezoid 2, so our left-hand side is going to be the 0.6, and our right-hand side is going to be the 0.691. So 0.6 plus 0.691 times, what's the distance between them? 0.74, yeah, it's irregular. Well, you can look for that in your quiz, something random like that. And so can someone go ahead and punch those numbers in and give me a... Kate? Do your hand up?
No, I was still stretched.
Oh, definitely a stretch. Bless you. Basically, whenever someone gets this, just tell me. I'm going to keep going with the next trapezoid. Trapezoid 3 is going to be 0.691 plus, this is 0.691, and the other one's going to be over here at 0.75. That's your second height. 0.75. What's the distance between them? From 2.24 to 3? Anybody? 0.76. Anybody get trapezoid 2 yet?
My calculator here. I'll do it. I'll do it.
Trapezoid 4 is going to be 1/2 times. Trapezoid 4 now, that's why I draw a picture. I think it makes it a little easier. 0.75 on the left, 0.783 on the right. Times the distance between them,
It's
0.6.
49058.
This one is?
I think so.
Say it one more time.
0.49058.
Okay, anyone get trapezoid 3 yet? How about this? Wilson, you do trapezoid 4, and Leo, you do trapezoid 3. Put those in the calculator and get an answer for me. All right, trapezoid 5 will be 1/2 times. This one's going to be on the left-hand side, it's going to be 0.783, and the right-hand side is going to be 0.8. So 0.783 plus 0.8 times the distance between them, 0.4. Kate, can you give me this one? 65. And then when we add them all up, we get our approximate. It's an approximation. Leo,
0.547.
which one we doing?
3.
0.54.
758.
758. Leo, Wilson. Still working?
I got 0.4559.
4559. And Kate,
I got 0.3166.
3166. Okay, so I need how about 3 different people add these up, make sure we get the right answer. Add all these up.
Wrong number, Mr.
Is it?
Yeah.
Okay, don't add them yet. What'd you get?
It's 0.4599.
Oh, okay, sorry about that. Okay, so let's get some number crunchers here. You add all these up and you get what? I heard someone said 2.08 what? 967. Can anyone else? Can I get 2 more people confirm that? Michelle got it. We good? All right. So this is our approximate area from 1 to 4 under this curve using trapezoidal. Okay. Now, what would we do? If we had to do this with midpoint, we would at first calculate what is the midpoint between these, then plug in that midpoint and get the height and use that. We could do that. Because we have the function, we could do that. But with a table, you cannot. If they give you a table and they don't tell you exactly what's at the midpoint, they don't give you a function, then you're shot of luck. So that's why trapezoid's more accurate than the right or left alone, but not quite as accurate as midpoint. All right, and now just a quick side, there's something called a Simpsons Rule. To be most accurate, you can use a Simpsons Rule. The Simpsons Rule basically says this. It's like a weighted average. That if you spent the time to calculate the midpoint and the trapezoid, you can figure out, you can weight this as 2 and weight this as 1 and take an average of all 3. So you do 7.75 plus 7.75 plus 8.5 divided out by 3. And so it's like a weighted average. You're counting the midpoint because it's more accurate, you're counting it as 2 times. The trapezoid counts as 1 time, you divide them all by 3. And now that's the Simpsons Rule, it gives you a more accurate prediction. Okay, it's not an AP/AB topic, but that is that's how you do it. Okay, the book talks about it's kind of long and complicated, but that's essentially the bottom line. Take 2 of these and 1 of those. Weighted average. Okay, what questions do you have?